Now, similarly for this question, the idea is we are adding an algebraic fraction. And so when we're adding a fraction, we will try to create the denominator and make it the same. Okay, recreate. So remember that the key steps always involves that you always probably got to factorize your denominator. Okay, you need to commence factorization, the denominator. And what are you doing when you are factorizing the denominator? Remember that you are using your four methods of factorization. And the first method, so remember the four methods, method one, that's always to do common factor first. Okay, always look for common factor and try to pull out common factor first. Okay, because a lot of times, if you can do common factor first, right, you do it. Whatever that remains, you may need to use, not like previous practice sets. You may need to use like, algebra identities. You may need to use grouping and so on and so forth. So, it can be difficult lah. It can be difficult, but it is fine. Okay, so you can use algebra identities. Remember, there are total 4 types of factorization. There is method 3, which is basically the frame or the cross method, which some of you all learn. Cross basically is the MMA, which I went through in earlier videos, as well as the frame method. And also method 4, which basically is grouping. Okay, grouping. Okay, so if you're not sure what are these, do refer to my other videos. Okay, so I'm going to think about common factor first, because that's always the first thing that comes to my mind when I try to factorize something. Okay, now if you look at each of these terms in the denominator, they do have common factor, right? So it's very obvious that you can see m seems to be a common factor. So if you observe, right, this can be written as m squared plus 2mn plus n squared. Okay, and next, look further. 1, 2, 3. What does this look like? Okay, also here to here, what I'm doing is I basically pull out a common factor, which is basically m. Okay. Now, what's my next step? The next step is, if you observe this further, right, it can actually be factorized again. Either you use the frame or you use the identity. Now, I'm just going to use identity. Okay. I can see that this probably look like, a square plus 2ab plus b square. Now remember, when we factorize a square plus 2ab plus b square, this actually is supposed to give us a plus b bracket square. Okay, so this is my a and this is my b. Your denominator now looks like that. It's just m bracket, remember, a plus b bracket square. So that is the denominator for you, right, after factorization. Okay, so next, this portion here, similarly, what do I do? Now you can factorize this as well. First method that comes to your mind, common factor. Okay, common factor. Now, if you observe these two, you should be able to see that, if I also do a common factor, you should be able to plot a common factor of m squared. Okay, so that gives you m squared and m squared minus n squared. Okay, a common factor of m squared gives you, pull out m squared minus n squared. Now, if you look at, again, just observe, can it be factorized further? Yes. M squared minus n squared, a difference of 2 squares, right? What does it look like? Remember this section here, when we factorize a squared minus b squared, all right, a form like this, right? This really looks like, in case you're not sure, just to use the template again, this looks like your a squared minus b squared, okay? Which, when you factorize, right, it should be equals to a minus b bracket a plus b. That is your factorization using algebra identity. So eventually, your denominator here gives you m squared bracket m minus n, m plus n. Okay. Okay, so far. And also that is your the groundwork that you have done even before you even start on the big picture of the question. So sometimes math is like that. You need to go macro then micro. Now, before you actually conduct the big scale operation, you have to fix the individual parts first. Okay, so that's what we're doing here. I want to show to you now our fraction now looks like that. Okay, our fraction now looks like that. Okay, this is what the fraction looks like now. Okay, it is basically 1 over m bracket m plus n bracket square plus n over m bracket m minus n m plus n. It will be easier for you this way to identify the common factors or to create the lowest common multiple. So if you look at the lowest common multiple, m plus n square, m plus n, m plus n, you can see that m is a common. So what I probably need to multiply by on the left-hand side is I will need to multiply by m minus n at the top. And over here, I probably need to multiply by another m plus n just to make it a square. And you can see that with that, both sides will have the same denominator. Okay, now once they are ready, I put them together, making sure that both sides now have the same denominator. Once the denominator is the same, I can add them together. N to m, that gives me nm. N to n square, and give me n square. Now with this, you can see that is it all good? My bad. Okay, I missed out one m square here. Okay, so it's actually m square, not m. Okay, so I'm rectifying on the go. So it means that here I probably need to multiply by another m. Okay, just to make it a square. So I multiply by m over m. So I create another m here. So this itself, m to m, that gives me an m square, n to m, that gives you an nm. Okay, so nm cancels off, and your final answer is just numerator m square plus n square. The denominator is m square, m minus n, m plus n square. Okay, now observe, if it's a sum of squares, it's not factorizable. Okay, only if it's the difference of square then can. Okay, so just take note. Okay, I mean, if you're not very sure about this, you probably need to go and revise your algebraic identities before you can actually understand this question. Okay.